Hi guys, welcome to Solubility. This was a video request from one of our students. So today we're looking at solubility. What is solubility? What are unsaturated solutions? What are saturated solutions? What are supersaturated solutions? What is anhydrous and hydrated salts? And some other things we'll be looking at. We'll start off with solubility here. It is defined as the amount of solute that dissolves in a particular solvent at a given temperature. Okay, so this is the definition for solubility. Solubility has the units mole per dm cube or mole per liter. So that means that the formula would be moles of the solute divided by the volume of the solution. Okay, so moles of solute is usually in moles, and the volume could be volume of the solvent or volume of the solution. So that's what I want you to take note of. So if you're new here, click the like button on this video and feel free to follow us if you want to learn more about chemistry. And also, if you have questions, you can leave them in the comments. Back to the arrangement here, we said you can have volume of a solution, or sometimes it could be the volume of a solvent. And apart from what solubility is, we've learned now that this formula here, moles of solute divided by volume of solution, helps us. Now we're going to check out what unsaturated solutions are. What does it mean when you say a solution is unsaturated? This means that the solution can still dissolve more solute at that particular temperature. That's why it's unsaturated. If it were saturated, then you would say that it cannot dissolve more solute at that particular temperature. Another important one here is a supersaturated solution. We already know what a saturated solution is. Can't dissolve more. But guess what? For it to be supersaturated, it means that it is produced when a saturated solution is cooled to precipitate the solute. So that now makes it supersaturated. Moving on to anhydrous and hydrated salts, really easy stuff. Anhydrous means dry, hydrated means wet. As simple as that. An example of a hydrated salt is Na2CO3.10H2O. And then if I remove the H2O there, then that gives me the anhydrous one. The H2O is the water of crystallization. That is what gets this salt hydrated. Okay, Na2CO3 is sodium trioxocarbonate 4. Very important basic solution there. Then another thing we're going to talk about, of course, is the very important solubility of solids and liquids and gases. Basically, as you increase the temperature, the solubility of solids and liquid increase. That's what you have on the left hand side. And then on the right hand side there, the solubility of gases decreases as you increase temperature. So please take note of this. For the solids and liquid, it's quite normal that if you increase temperature, solubility increases, yes. But for gases, different. It actually decreases. So the question is, why? Now imagine this, you have this beaker, right? And then some gas molecules are inside this beaker. Probably they were in the liquid form before, and then you heated, it became gas, yes. And then gases, basically, when they go up, they tend to exert pressure on the liquid. Okay, that's what we call partial pressure and stuff like that. But the main reason is the increased kinetic energy. As you are heating the gas molecules, what do you expect? They would keep moving, random motion, right? And then they get out of the solution. So they don't even dissolve as good as a normal solid or liquid. Yeah, so increased kinetic movement. That's the reason. Now over to the solubility curves. It's very interesting. It helps us to check our temperatures and the corresponding solubility. We'll just draw the curve here. This is just a sketch. So many salts here: KCl, potassium chloride, sodium chloride, that's your common salt, KClO3, that's potassium trioxochlorate 5. Now these salts, they have different solubilities at different temperatures. What I have at the bottom there is the temperature, and then on the y-axis there, that's the solubility. So you can see that you can actually trace it at 80, at 120, trace it to the curve just like I'm doing for KCl here, and then you know that that is the solubility of KCl at 120 degrees Celsius. So I want to show you something real quick. Look at this 80. If you trace it down, you get a solubility there, let's say 12. Trace 40, you get a solubility there. It has reduced now to, let's say, 5 or so. So that shows you that as you are cooling this salt, the solubility is reducing. We already agreed. Yes. So the cooling leads to a reduction in solubility that is known as precipitation. Now we're heading over to questions here. I hope you're ready. So this one says 23 grams of KCl is dissolved in 100 cm³ of water. We want to calculate the solubility of the salt. First thing to do, calculate the molar mass of KCl, right? Then next, you want to map out the volume of water as 100 cm³, so that's why all that was done. The solubility is therefore the mass over this volume here, because they wanted it in gram per dm³ for that question. And then this next one has to do with calculating the solubility of the salt. The molar mass of the salt first, you calculate that. Yep, 331 grams per mole when we put everything in there perfectly well. And you also need to get the moles of the solute itself. Remember, solubility is moles of solute divided by the volume of the solvent or solution. So we get the moles of the solute, which is the mass. 12.2 divided by 331 will give you that in moles. Apart from this, we'll need to get the volume of the solvent. The said is 21 grams of water, but I'm writing 21 cm³ here. Why? Because it's water, and for water, the density is 1 gram per cm³, meaning that 1 gram is actually 1 cm³. So 21 cm³ is for the 21 grams. Convert that to dm³, you have that value there. Get the solubility, moles over volume, and you slot in your moles 0.0368, your volume as well in dm³, and that gives you your answer as 1.755 moles per dm³. Next up is the next question. This one is a bit tricky because it has to do with a reaction. First, if you read the question very well, you see it has to do with a reaction. So you have to write out the equation of reaction between sodium chloride and silver nitrate. Now we're breaking sodium into its ions and the silver nitrate as well. Positive goes to negative here, so we form the first compound, NaNO3, plus the Cl goes with the Ag, and you get AgCl. Okay, so the main reason of doing all this stuff is so that you can know that 1 mole of NaCl reacts with 1 mole of silver nitrate. So that means that the moles of silver nitrate is the same as the moles of sodium chloride. Okay, but the moles of silver nitrate is actually concentration times volume. So we went ahead to do the concentration multiplied by the volume. And then cm³ is the same thing as mil. So remember, mil, that's ml, milliliters, is the same as cm³. So I just did the conversion here so that I'll be able to obtain the moles of silver nitrate in this particular question. And that was 0.032 moles. Hence, you can get the moles of NaCl as well as the same thing. And then we can proceed to get the solubility. So if you have questions on this, feel free to DM us or send a message on Instagram. We're always there to reply to you. quickly as well. Yes. So this is what we love doing, teaching people chemistry and also helping with your assignments. Of course, this would be YouTube. You'll be watching the full video here. And that's number there. That's a WhatsApp number or iMessage number. You can reach out to us if you have assignments that you need help with or tutoring. Okay?